In today's lesson, we are going to look at combustion. Your success criteria for today are that you have been a successful learner if you can identify and write the word and formula equations for complete combustion, and identify and write the word and formula equations for incomplete combustion. Combustion is another term for burning. In our lesson on fuels, we discussed that the burning or combustion of fuels was an exothermic reaction. Exothermic reactions release energy to their surroundings, mainly in the form of thermal or heat energy. However, light and sound energy are also released. In the case of burning a strip of magnesium, for example, when you burn the magnesium in a Bunsen burner flame, there is an extreme amount of bright white light energy that is given off. Combustion reactions require three conditions be satisfied for them to occur. They need oxygen, heat, and fuel. In class, our source of oxygen would come from the air in the classroom. Our heat source would be our Bunsen burners. And the fuel that we want to combust would most likely be a simple short chain hydrocarbon. If one of those three conditions is not met, then a fire will not start. If we wanted to stop our combustion reaction from going any further, then we could remove any one of these three conditions and the fire would go out. There are two different types of combustion reaction: complete and incomplete combustion. When a fuel burns, the hydrocarbons in it react with oxygen to form new products. If there is plenty of air, therefore plenty of oxygen, then complete combustion occurs. In complete combustion, the hydrogen atoms form the hydrocarbon, combine with oxygen from the air to make water vapour, and the carbon atoms from the hydrocarbon combine with oxygen to form carbon dioxide. This results in the maximum amount of energy being released. Here you can see the word equation for complete combustion. Hydrocarbon plus oxygen will produce carbon dioxide and water. An example of a complete combustion equation can be written for propane. C3H8. So propane is our hydrocarbon. We add oxygen. We know that oxygen is diatomic. Remember, I bring clay for our new house. Carbon dioxide, di meaning two. So we know we're going to have two oxygens in our formula. And water with the formula H2O. We need to balance that equation to make sure that we have the right amount of each atom on both sides of the arrow. And there you have a fully balanced combustion equation for propane. Incomplete combustion occurs when there isn't enough oxygen present for complete combustion to happen. Instead, what we get is water vapour is produced, and we have two different products that are produced. One of these is carbon monoxide, which is a poisonous gas that is absorbed in the lungs and binds with the haemoglobin in red blood cells. This means that these blood cells can therefore no longer carry oxygen around the body. Our other product is particle of carbons which appear as soot and smoke, and these cause breathing problems because they clog up the lungs. Here we have the word equation for incomplete combustion. Hydrocarbons plus insufficient oxygen will produce carbon monoxide and carbon in the form of soot and water. We are going to do another example using propane. Remember, propane is C3H8. And this time, for incomplete combustion, we would have the products carbon and water. we don't have carbon monoxide formed by the incomplete combustion of propane. Now we still have to balance this equation, so make sure that you're undergoing that step. And there we have the balanced incomplete combustion equation for propane. That's all for today on combustion, but make sure that you go into your class notebook and complete the accompanying exercise.